VLSos here. This is a video lesson on magnitude, the magnitude of a number. Another term for magnitude that means the same thing that's been popular in the past is absolute value. When we ask the magnitude of a number, we could also ask the very same question, what is the absolute value of a number? And what we mean by the magnitude of a number in mathematics is we find it as the distance between the number and the origin, or zero. And a number line can help us for example, find the magnitude of the number -4. The magnitude of -4, or the absolute value of -4, is the distance between -4 and 0 on the number line. So if we use a number line to visualize, and we locate 0, and we put a tick mark at -4, the magnitude of this number is this distance. And the distance between -4 and 0 is 4. We have a way of symbolizing this question, or this operation of finding the magnitude of a number. We use an odd group of parentheses, which are straight vertical lines. We can think of these as magnitude bars or absolute value bars, and what we put inside is what we're trying to find the magnitude of. So using this symbol, I'm writing down the magnitude of -4. And I can evaluate this because I know that it is +4. We can call the use of this particular set of parentheses, this symbol, absolute value bars, or magnitude bars. Now, this idea of the magnitude being the distance between the number and 0 as the definition of absolute value or magnitude is very helpful, especially much later in mathematics. But most at the algebra and pre-algebra level of math think of taking the absolute value of a number as understanding this. If it's negative, make it positive. If it's positive, keep it positive. So the absolute value of a number is not the same thing as changing its sign. Here's another example. I'm using the absolute value bars to ask what is the absolute value of 3. And what that means is, on a number line, the distance between 3 and 0. And that distance is +3. So the absolute value of 3 is +3. In this case, it was positive and we kept it positive. Another example. the negative of the absolute value of -8. Now we have to be careful that we're taking the absolute value of what's inside those absolute value bars. And the absolute value of -8, we can think of it as, if it's negative, make it positive, which turns it into a +8. But this expression came with a negative out front also. And this negative is still there, making the final answer -8. One more. The magnitude of 2 times -3 minus 10. I'm going to simplify this expression. In this case, in the order of operations, I'm not going to subtract this 10 first. These absolute value bars are a grouping symbol. So in GEMDAS, the G comes first for grouping. And I look inside to multiply the 2 and the -3. 2 times -3 makes -6. I'm still taking the magnitude of that number inside and then subtracting 10. The magnitude of -6, the distance between -6 and 0, is positive. I made that -6 positive. And then I subtract 10 to get a negative answer.